Alright everybody, welcome back to Mr. Buckingham's Physics Problem Solutions. We're doing problem number 3 from our kinematics problems. Alright, so this problem has a couple of interesting parts in it, and it actually breaks it down into an A, B, and C to kind of help us get from the beginning to the end. Alright, let's go ahead and read the problem. A stunt woman falls from the top of a building while filming a movie. She strikes a safety airbag at the bottom, moving 30 meters per second. We're going to go ahead and reread this time underlining any of the important things. So a stunt woman falls. Okay, we're going to underline fall because that tells us something. From the top of a building while filming a movie. She strikes a safety airbag at the bottom, moving at 30 meters per second. Alright, so we've got a little bit of information, but not a ton. We're going to go ahead and pull that information and start to answer this. Alright, so Part A, how many seconds did she fall? Alright, so what we're looking for is how long was she in the air for? We're going to use a pretty simple formula here, which is V equals V naught plus AT, okay? And what we need to do is actually write down some of our given information, and then we're just going to plug in. So we know our initial velocity, anytime that something is just falling, okay, or that it's just let go or something like that, our initial velocity is 0 meters per second because it starts from rest. Our final velocity in this case, VF, is 30 meters per second. Alright, and now what we're going to do is we need to actually calculate for how long it took to get to that speed. Alright, so now we're going to go ahead and plug in our values. I've got my final velocity of 30 meters per second is equal to V naught, which is 0, plus the acceleration. Here we need to remember that acceleration of anything falling is g. Okay, that's 9.8 meters per second squared. Alright, so we're going to go ahead and plug g in here. It's 9.8 meters per second squared times our time, t. And right now, what we're going to be doing is solving for t. Alright, so we've got 30 meters per second divided by 9.8 meters per second squared is equal to t. That means that our time for the first part is going to be equal to 3.06 seconds. And then we're going to circle our answer, making sure that we do that so that we know which is our answer and what we want the person to know about. Alright, let's go ahead and move to part B. What was her average speed during the fall? Okay, if we look at the hint here, it says, assume she was traveling the same speed the whole time. Anytime that we're doing our average speed, what we're trying to say is, what if they were going the exact same speed the entire time? That is, from the start time to the finish time, that she was going the same speed. Now, this one might seem a little bit daunting, okay? But we don't have to let it be daunting. We don't have to let it be scary. Again, we're trying to find the average speed here. So we're going to pull average speed from our formula sheet. We're going to use a form that looks like this. It says V bar, that is V average, is equal to V naught plus VF over 2. Okay? Now I'm not going to get into why this all works the way it does. Just trust me that it does. Okay? So now we're going to be calculating the average velocity. We have our initial, we have our final, and now we're just going to do the sum of those divided by 2. That is to say that V bar is equal to 0 meters per second plus the final speed of 30 meters per second divided by 2. That gets us an average velocity of 15 meters per second. There's our answer. And let's think, does that make sense? And it really does make sense. That would mean that during the course of her fall, okay, she averages this much, which should be less than the peak speed. Because if we remember, this is accelerating up to this speed. This would be the constant speed that you cover the same amount of distance. Alright, and now we're going to say part C, from what height did she fall? So now what we're trying to do is find what is the change in height, delta V. We just calculated the average velocity, so we can use that to our advantage. And that V bar, or average velocity, is the change in x over the amount of time it took to do that. We're looking, again, for delta x here, right? We want the change in height. How far did she fall? Okay, so we're going to rearrange some things, and we have that x is equal to velocity times time. And really, that's V bar, right? The average velocity. So we'll go ahead and plug that in. Our velocity of 15 meters per second times the time that it took to fall, which is 3.06 seconds, gets us the change in height. Alright, now it might be tempting in here for your change of height, or for your speed, your velocity, to put the wrong speed in. Remember, we're assuming that this person is going the same speed from the top of the fall all the way to the bottom of the fall. Okay, so then our height, which is 15 times 0.306, is 45.9 meters. Alright, just as some kind of ballpark numbers to try to think about how far that is. 45 meters is somewhere on the order of 150 feet. That's about 15 stories or so. Right? We're looking at quite a long fall. That's a very long ways to get up to 30 meters per second. That's really moving by the time she hits the end. But this does make sense. We're not seeing that she's falling from a skyscraper, or she's falling from outer space or something like that. She's also not just falling from the top of a tabletop. She's falling a pretty long ways to get up to that 30 meters per second that she initially was, that we were told that she's going at the end. Okay. Hopefully that helps. If you are not understanding any of this, remember to take it step by step and come see Mr. Buckingham if you have any questions.